So the first match the column, it simply says that match the entries of column 1 with one or more entries of column 2. A part says that the plane passing through the intersection of planes P1 x plus y plus z equal to 0 and let us say P2 x minus y plus z equal to 0 and perpendicular to the plane x plus y plus z equal to 0 passes through the points, and we have 5 options correspondingly. Students, we know the family of planes is P1 plus lambda P2. So writing P1 plus lambda P2 and applying the condition of perpendicularity with this particular plane, that is P1 itself. So we have P1 plus lambda P2 is equal to 0, where P1 is x plus y plus z equal to 0 and P2 is x minus y plus z is equal to 0. So we have 1 plus lambda of x plus 1 minus lambda of y plus 1 plus lambda of z equal to 0 as the family of planes passing through the intersection of these two planes. Now this is perpendicular to x plus y plus z equal to 0. So dot product of two normal vectors is 0. So we have 1 plus lambda into 1 plus 1 minus lambda into 1 plus 1 plus lambda into 1 equals to 0. So lambda is equals to minus 3, which will give me minus 2x plus 4y minus 2z is equals to 0. So that is x minus 2y plus z is equals to 0. So it passes through 0 comma 0 comma 0, correct. 1 comma 1 comma 1, correct. 1 plus 3 minus 4, 1 to 3 is also correct. 3 to 1 is also correct. 4 0 minus 4 is also correct. So PQRST, all 5 options are correct corresponding to entry A in column 1. Let us move on to B. Again, the plane passing through intersection of these two planes, same plane, 1 plus lambda into x plus 1 minus lambda into y plus 1 plus lambda into z equals to 0, containing this particular line. So direction ratios of this line and the direction ratios of normal vector are going to be perpendicular. That means the dot product is 0. So 1 plus lambda into 2 plus 1 minus lambda into 1 plus 1 plus lambda into minus 2 equals 0. From here you get lambda equals 1. So if you get lambda equals 1, equation of plane is x plus z equals to 0 or 2x plus 2z equals to 0. First point right, second not correct, third not correct, fourth not correct, fifth correct. So PT is the correct match for option number B. Okay, let us move on to the next part. The line passing through the intersection points of x upon 1 equals y upon 2 equals z upon 3, x upon 3 equals y upon 2 equals z upon 1. Obviously the point of intersection is origin. For the second, and the intersection point of x plus 2 upon 3 equals y plus 1 upon 2 equals z upon 1 and x minus 2 upon 1 equals y minus 3 upon 2 equals z minus 3 upon 4. So that means 3 lambda minus 2, 2 lambda minus 1, comma lambda is equivalent to mu plus 2, 2 mu plus 3 and 3 mu plus 4. From here you will get lambda equals 1, mu equals minus 1 and the point of intersection, let us say point Q is 1 comma 1 comma 1. The first point, let us say point P is origin. So I need the equation of line which is passing through P and Q. The equation of line is x upon 1 equals y upon 1 equals z upon 1. Okay, that means x minus 0 upon 1 minus 0 equal to y minus 0 upon 1 minus 0 is equal to z minus 0 upon 1 minus 0. It passes through the point. All the three coordinates should be equal. Only P and Q are correct. P and Q for option number C. Let us move on to next part. The plane containing the lines x upon 1 equals y upon 2 equals z upon 3 and x upon 3 equals y upon 2 equals z upon 1. So if the plane is containing the lines, so x minus 0, y minus 0, z minus 0, because both the lines intersecting at origin, the direction ratios of both the lines are perpendicular to the normal vector. So we have 1, 2, 3 here and 3, 2, 1 here equals to 0. You'll get x minus 2y plus z equals to 0, which is same as A part. So PQRST is the correct match. Okay. Let us move forward to the next match the column. Question number 57, it has the same statement, match the entries of column 1 with one or more entries of column 2. Fx is a function which is given in the form of integration 0 to x squared t minus 1 into t minus 4 dt. Then we have to find out the points of maximum minima or the points of inflection. f dash x straight away by applying Newton-Leibniz theorem, 2x into x square minus 1 into x square minus 4. So f dash x has 5 critical points. So f dash x is equal to 0 for 5 different points. X equal to 0, x equal to 1, x equal to 2, x equal to minus 1 and x equal to minus 2. So let us analyze f dash x over the number line. 0, 1, 2, minus 1, minus 2. Positive, negative, positive, negative, positive, negative. From negative to positive we have a point of minima. So 0 is also point of minima. This is also point of minima. The remaining two are the points of maxima. Out of the first three, this is wrong. 3 point of maxima, wrong. R is correct. Now let us talk about points of inflection. Students, we know that f dash x 5-degree polynomial, it has 5 roots, and we also know the fact that for a polynomial function, between every 2 roots of fx, there exists exactly 1 root of f dash x equal to 0. So for 5 roots of f dash x equal to 0, we will have 4 roots of f double dash x equal to 0 over there. That means we have 4 points of inflection straight away. So we have R and S as the correct choices. Okay. We can also visualize that according to the graph of f dash x. So this is going to be the rough graph of f dash x. So we have 1, 2, 3, 4 points where horizontal tangent is there. That means f double dash x is equal to 0. Definitely 4 points of inflection. Let us move on to B part. Fx is equal to cos x from minus 2 pi to 2 pi. Very simple graph. 0 to 2 pi and similarly minus 2 pi to 2 pi. So closed intervals. How many points of minima? 2 points of minima. How many points of maxima? 3 points of maxima. Wrong, correct, wrong. How many points of inflection? Concave down, concave up, concave down, concave up, concave down. 1 point is here, 1 point is here, 1 point is here, 1 point is here. 4 points of inflection. This is wrong. QS is the correct match. Fine. Let us move on to C part. Talking about fx as sine cube x, where x belongs to minus pi to pi. So f dash x is 3 sine square x into cos x. So f dash x is equal to 0 in this interval at x is equal to 0, where sine x is 0, x is equal to minus pi by 2 and x is equal to pi by 2. Right? So students, we have to consider the graph between minus pi to pi, minus pi by 2, 0 and pi by 2 are 3 points of consideration. These are the 3 critical points. After pi by 2, that is in the second quadrant, f dash x is negative because sine square x is always positive anyhow. So cos x is negative, that means f dash x is negative. From 0 to pi by 2, f dash x is positive, but from minus pi by 2 to 0, just because sine x has a double root, the sign of f dash x will not change along 0. So it is still positive in the fourth quadrant because cos x is positive. That is the second reason. From minus pi to minus pi by 2, that is the third quadrant, it has to be negative. So we have this as a point of minima. We have pi by 2 as a point of maxima. And we have 0 as a point of inflection. So going along the first 3 options, 1 minima and 1 maxima, P is correct, Q and R both are wrong. Now let us talk about the number of points of inflection. Will go in the same way. We'll draw the graph of f dash x and we'll conclude the number of points of inflection from there by checking the roots of f double dash x over there. From 0 to pi by 2, f dash x is positive. It is 0 at 0, 0 at pi by 2. Something like this. Then something like this in the second quadrant because it is negative. In the fourth quadrant, cos x is positive, sin square x is positive, so this is positive. This is the graph of f dash x I am drawing, students. Negative in the third quadrant. The number of horizontal tangent in the graph of fx will give you the number of points of inflection. 1, 2, 3, 4 and 5th point of inflection. In total we have 5 points of inflection. So final answer of this part is pt. Okay, let us move forward to the last part. Again, we just now did sine cube x, now we have to do cos cube x. So f dash x is 3 cos square x into minus sine x. Again, the interval has been changed in the question, minus pi to pi by 2. So let us draw the graph and analyze f dash x over there. Minus pi, 0, pi by 2, minus pi by 2. F dash x is 0, again at x equal to 0, minus pi by 2 as well as pi by 2, but that is not included in the interval. Now, in the first quadrant from 0 to pi by 2, sin x is positive, cos square x is positive, so f dash x is clearly negative. Along 0, it is bound to change the sign. In the fourth quadrant, sin x is negative, so it is positive. In this particular quadrant, cos square x is positive, sin x is negative, so it will not change the sign. So we have 0 as the point of maxima, minus pi by 2 as the point of inflection. Now let us draw the graph of f dash x again. Positive in this part, then again positive in this part, and then negative in this part. Clearly students, 3 points where we can see the horizontal tangents. 1, 2, 3, and the fourth one is minus pi by 2. So in total 4 points of inflection S, as well as 1 point of maxima P. Answer for this particular question is PS. So with this, we are done with this section. Let us move on to integer type problems now.